Hello dear aspirants, welcome to AMDOOR Educational Academy. In this video, I am going to discuss the solutions of digital electronic subject from the GATE 2026 EC paper. Here I have collected the questions from the GATE 2026 EC branch paper from the digital electronic subject. Based on the GATE 2026, totally 13 marks were given in GATE 2026 exam. Now I am going to discuss the complete solutions of those digital electronic questions from the GATE 2026 EC branch paper. Yeah, first of all, we'll go through this question. This question comes under 1 mark question. And first of all, please read the question. In the circuit shown in the figure, A and B are logic inputs and Y is a logic output. Which of the following logic operations realized by the circuit? So here one simple circuit is given. From the circuit, just we have to identify the circuit acts as which type of a gate. So if you know the logic families concepts are there, NMOS and PMOS and CMOS. So if you know that concept, then we can write directly from the simple shortcut technique. Just identify the transistors. So here arrow mark is given outside. So this is acts as a NMOS transistors. These two are acts as NMOS transistors, and these two are acts as PMOS transistors. So now it comes under the CMOS logic circuit. So whenever NMOS transistors are connected in parallel and PMOS transistors are connected in series, then it performs the OR operation. So just we have to write OR operation of the input. Here A input is there and here B input is there. Then write the output expression Y is equal to A plus B. And later we have to identify the complement operation again, because this in CMOS logic NMOS switches are connected parallel with the load, then it performs a whole complement. Compulsory we have to write the whole complement. Now A plus B whole bar. So this is the final answer. This is acts as a which operation now? NOR gate. So if you know that logic families concepts, we can write the answer directly. So to write this answer, it takes only 10 to 15 seconds, because this is one of the very easy and simple and repeated question. And sometimes we can find this answer. So I will explain some other method also, because we have to find out sometimes using switch operations also, because here this is a standard question. Sometimes we can expect the question in different connections also. So that purpose, I will explain the standard method how to find out the complete logic without using this standard representation. So here PMOS transistors are access switches and NMOS transistors are also access switches. So just I am drawing the PMOS switches. Two PMOS switches are there. Those are connected in series, and NMOS switches are connected in parallel. This should be like this. And it is connected to ground, and here it is connected to the power supply plus VDD. And here you have to remember one thing here, PMOS transistors and NMOS transistors are acts as alternative switches. So whenever the NMOS transistor operates in on state, PMOS transistor has to operate in off state. So both are acts as alternative switches. Now these two are connected in series and these two are connected in parallel. So I wrote these diagrams, and just I am writing here A, B operations. And here exactly it performs the alternate operations. That's why here I'm writing A bar operation and here B bar operation, because exactly it performs the opposite operations, right? So again I'm writing the truth table here. Just we have to take the output from this point and prepare one truth table A, B and Y. First of all, I'm assuming A and B both are 0, 0. Both are 0, 0. Now see, this switch is 0 and this switch is 0. 0 means based on the positive logic, we have to assume it is an open circuit. If it is 1, then closed circuit. So A switch is open and B switch is also open. These two are acts as open circuit, but here A bar connected and B bar connected. Now these two becomes 1. That's why this one is closed and this one is closed. So whenever these two switches are closed and these two are open circuited, the complete current flows through the load. Because these two are open circuited, now whatever the current comes from the VDD, this is directly connected to the load side, so output gives the 1. So we will get the output is a 1. And similarly, I am taking another combination 0, 1. So 0, 1. A is 0 and B is 1. So A switch is opened and B switch is closed. From these two, any one switch is closed, then the complete current flows towards the ground side. and from these two any one switch opened, then this power supply disconnected from this circuit, because if it is open circuit, it is acts as a very high resistance device, so total voltage drops occurs here only, so that's why we will get the output is 0. So whenever from the A and B any one switch is 1, any one input is 1, then the output should be always a 0. That's why I'm writing 1 0 combination 0, and both are 1 1 is also 0. Now coming to this truth table, this truth table explains if all inputs are 0, then the output is 1. If any one input is 1, then the output is 0. This is explained by the NOR operation. So that's why this is acts as a NOR gate. So directly we can write the expression A plus B whole bar. So this is also one of the simple question and a very easy question and scoring question also. So this question is comes under logic families concept, and it is a 1 mark question. Another question from the digital electronics subject. This question comes under the sequential circuit. First of all, please go through the question. A binary ripple counter is designed to counter 0. This is 0, base 10 is there, to 64 base 10. Right? So a binary counter has to count from the 0 to 64, and which of the following is the number of flip-flops required to design the counter. So just we have to identify the number of flip-flops only. And here clearly mentioned, it has to count from the 0 to 64 onwards. First of all, please go through this number, 64 number. If you write this 64 number in terms of binary format, 64 in terms of binary format, then the number gives the 1 0 0 0 0 0. Yes, because see, this is a comes under 1's position, 2's position, 4's, 8, 16, and again right here 0 and 1, 32, and here this one is comes under 64. So if you write this 64 number into binary format, it requires totally how many bits? 1 2 3 4 5 6 7. 7 bits are required. So this one is the maximum number. So to count that number compulsory, it requires 7 flip-flops, because one flip-flop can count only 1 bit only. So now here 7 bits are there, so compulsory it requires 7 flip-flops. So we can write the answer from this directly like this, 7 flip-flops. This is one simple processor. If you convert the maximum number into binary format, then it gives this one. Otherwise, we can follow some other method also. Another method is a second method I'm explaining here. Based on the counters concept, ripple counters. Ripple counters are nothing but asynchronous counters. In asynchronous counters, using n flip-flops, it can counts, which can counts 2 power n combinations. So ripple counter can count 2 power n combinations using n number of flip-flops. Here n explains the number of flip-flops. Now we want here how many combinations. If it starts from 0 to up to maximum 64, then it gives you total number of combinations, 65 combinations. So number of combinations should be 65 based on the question. Total number of combinations 65. You have to count 0 also. 0 to 64, 65 combinations are there. And using this formula, just I am assuming here n is equal to 6. If it takes n is equal to 6, the maximum number of count should be 2 to the power of 6. 2 to the power of 6 is 64. So using 6 flip-flops, it can count only 64 combinations. But based on the question, we want here how many combinations? 65 combinations, more than that. That's why we have to take n value should be 7. So I'm taking here n is equal to 7. Then 2 to the power of 7 is gives the totally 128 combinations. Right? So based on the given answer, so here 7 satisfies, 6 does not satisfy, 5 also does not satisfy, and some 8 also satisfies based on this one now. If you take n is equal to 8, it can count up to 256 combinations. But we want how many combinations? 65 combinations. So we have to take the minimum number of flip-flops only. So minimum number is compared to 8, 7 is the minimum number. That's why this 8 is also wrong answer. Just we have to write 7 only. Otherwise, we can use a standard formula from the counters, from the ripple counters, asynchronous counters. We have one standard formula. Number of flip-flops n should be greater than or equal to log base 2 k. This one standard formula is there. Here k explains the number of combinations. K explains the number of combinations. Here, how many combinations are there? 65 combinations. If you substitute that value, n is greater than or equal to log base 2, just write 65 combination, then approximately it gives the 7 number, because always we have to take up n value should be integer value. This value should be integer value. Number of flip-flops always defined in integer format. So you have to take integer value. If you simplify this value, then it gives the 6 point something. If the value is greater than the 6, compulsory you have to take 7 only. So based on the given question, answer B correct. Option B correct answer is 7 only. Another question from this concept, a negative edge triggered JK flip-flop has JK inputs tied to logic high and square wave of 10 cycles per second is applied to its clock input. The frequency of the output Q is just it is comes under numerical answer question. Just you have to write the complete answer in numerical form here. There is no options here, so enter the correct value here. So based on the given question, it has a JK flip-flop. Let us take this is only JK flip-flop, which has two inputs, J and K, and J and K inputs are 1, so JK should be 1, and this should be negative edge triggered flip-flop, so negative edge triggered flip-flop, which gives you two outputs, one is Q and another is a Q bar. And now, whenever JK flip-flop inputs are 1, both inputs are 1, then it operates in toggle mode. In toggle mode, JK flip-flop acts as a frequency divider. So in toggle mode, JK flip-flop acts as a frequency divider. So based on the given question clearly mentioned, the input frequency is here 10 cycles per second, that means 10 hertz. Then the output frequency of this one is input frequency by 2, because it is acts as a frequency divider. So input frequency is 10 by 2, then it becomes 5. So finally, what is the answer now? 5 hertz. Just you have to write this answer here, 5. So this one is also comes under 1 mark question. What is the question? The address of the first location of a 256 kilobyte memory is 2500H. Starting address of the memory given here, and choose the correct address of the last location of the memory. First of all, just identify the memory capacity. Memory capacity is 256 kilobytes. So I'm writing that part now. 256 kilobytes. From this, we have to identify the number of address lines. 256 kilobytes memory capacity. From this, identify the number of address lines. To identify the number of address lines, we require always the standard representation of the memory. How to represent the memory? The standard representation should be like this: 2 to the power of n by m. Here, this n explains the number of address lines, and this m explains the number of data lines. So we want only address lines because we have to find out the starting address and ending address. That purpose, try to convert this complete number in this format. So I am writing here 256. 256 in terms of 2 power is 2 to the power of 8 into k is given here. K means kilo. So in binary format, the kilo value should be how much here? 2 to the power of 10, and this b explains the 8. Now finally simplify this. It becomes now 2 to the power of 18 by 8. So based on the standard representation, this memory requires totally 18 address lines. 18 address lines. So using 18 address lines, identify the starting address and ending address. How to write the starting address? In semiconductor memories, always we have to use binary data representation. Just enter 0 for the starting address and enter 1 for the ending address. Now total number of bits, how many bits are there? 18 bits are there. Just I'm writing here starting address 18 zeros. Similarly, ending address EA I'm writing here, ending address is 8 ones. Hexadecimal representation. So please convert this binary representation into hexadecimal format. So how to convert? From the right side onwards, divide 4 bits. So 4 bits are divided like this. Then write the starting address. The starting address should be 0. Here only 2 zeros are there. We can write 0. So 0, 0, 0, 0, 0, H. In terms of hexadecimal, compulsory you have to write H. And this one is acts as a F. And here F. This is F and this is F. And what about this one? Only 2 ones are there. This value should be 3. So now the ending address is 3FFFH. So starting address, ending address based on the number of address lines, based on the memory capacity. But based on the given question, this is considered the starting address is already mentioned here. How much? What is the address? 2500HS is the starting address. That means already one memory is defined like this. Within this memory starts from the 2500H location, not from 00. So this one is the starting address. So 2500H. Now identify what is the ending address here, and the location, the capacity of this one is 256 kilobytes. So to identify that ending address with this starting address 2500, just add that address to this ending address of this one 2500, then add these two, then you will get the ending address of this F, and here it is F plus 5. Use hexadecimal addition representation. F equivalent value is 15. 15 plus 5 is 20. 20 minus 16 is a 4 with one carry right here like this. And again F is 15 plus 3, 18. 18 minus 16 is 2 with one carry. 3 plus 1 is 4. Now finally, what is the ending address? 424FFH. So please go through the options here. 2FFH is there, so this one is wrong. 124 wrong, and 424FFH. So this is comes under the correct answer, and this is also wrong. Now finally, we can find the starting address, ending address using this procedure, and this is also one of the very important concept. To understand this, you have to understand from the semiconductor memories concept from the basics onwards. So what is the use of the address lines, what is the use of the data lines, and the memory definition, memory, how it is arranged, and what are the standard types of the memories, RAM and ROM. So complete concept comes under the semiconductor memories only. So if you know that concept, then you can write this answer directly. So this one is also one of the very simple question, and it is comes under 2 marks question. So in GATE 2026 EC paper, this was given in a 2 marks question. So we can find this answer within the 30 seconds. So we will get the 2 marks easily from these type of questions. First of all, we have to understand the concept only. So AMDOOR Educational Academy is providing the complete coaching for the GATE classes, especially for EC and electrical branch, and we are planning to take the classes for the CS branch also. So those who are interested to take these courses from the AMDOOR Educational Academy, please download the app AMDOOR Educational Academy and go through the courses. A simple question is given: what is the tens complement of 47? This number is a 47 with base 10. Right, base 10 explains there is a decimal number. Just we have to identify the tens complement. Right, so this is also one of the simple and easy question, and this was given in a 2 marks session, 2 marks question. So it is also comes under the 2 marks question, and this question is one of the simple question. Just you have to understand, you have to know the concept of complements. So I will explain that concept now. Generally, the complements are classified into 2 types. One is R-1's complement. Here R is a base of the number system, that is a radix, and another is a R's complement. So complements are 2 types: R-1's complement and R's complement. Now here, what is the R here? R is equal to 10. So using that R is equal to 10, we have totally 2 types of complements: 9's complement and 10's complement. And based on the question, we require a 10's complement only. But if you want to find out the R's complement compulsory, we require R-1's complement. What is the standard procedure here? So the procedure is like that. First of all, we have to find out R-1's complement. Later add 1 to this. And how to find out the R-1's complement? Subtract a given number from the maximum possible number. So here the decimal number is a decimal number, maximum number should be 9. In decimal number system, maximum number is 9. So using 2 digits, the maximum number should be 99 using 2 digits. And subtract a given number. What is the number here? 47 is given. So minus 47. Subtract these two. 9 minus 7 is 2 and 9 minus 4 is 5. This is comes under 9's complement of the given number. But we want 10's complement, that's the R's complement. That's why add 1 to this. Then we will get the number 53. So finally, what is the answer now? 53. 10's complement of the given number is 53. Go through the option. A option wrong and B option correct and C wrong and D also wrong. Finally, B option is the correct option based on the given question. The question from this concept: a Boolean function f of xyz with x as MSB and z as LSB is realized by 4:1 multiplexer with selection lines S1, S0. And here S1 is a MSB and S0 is a LSB, and inputs I0, I1, I2, I3 as shown in the figure. So here simple one, 4:1 multiplexer is given here. Totally I0, I1, I2, I3, these are the inputs and these two are the selection lines. And here we have to assume S1 is MSB. This is acts as a MSB bit and this one is acts as a LSB bit. So the order should be like this: MSB this one, and here this one is a LSB, X, Y, Z order. Just we have to find out what is the output or expression of this circuit, right? So it's a 4:1 multiplexer. To solve this problem, just we required the standard output equation of the 4:1 multiplexer. What is the output equation? Go through the selection lines. Selection lines here, one is X and other is Z. Using those selection lines, I am writing the equation: X bar Z bar I0 plus X bar Z I1 plus X Z bar I2 plus X Z I3. This one is the standard output equation of the 4:1 multiplexer. If you know this equation, then we can solve this question within 20 seconds, right? So just substitute this I0, I1, I2, I3 values based on the given question. Now here I0 is 1, so here I am substituting 1, and I1 is 0, so this is 0, right? And I2 is also 1, here I am writing 1, and I3 is a Y. Replace all this, then write the equation: X bar Z bar 1 plus this becomes 0, plus here X Z bar I2 is also 1, and here I3 value is Y. We have to write in order. Compulsory, you have to follow the order X, Y, Z. That's why I'm writing here X, Y, Z. Then simplify this. How to simplify? Use Boolean algebra techniques. Then simplify this. From these two I'm taking Z bar common. Then the X plus X bar becomes 1, plus here X, Y, Z is there, and here Z bar is there and here Z is there. Apply absorption theorem. So complement of this is Z, so remove that. Then write finally answer X, Y plus Z bar. This one is the final answer. Then go through the options. Simple simplification. Just we have to know the Boolean algebra techniques and combinational circuits like multiplexer operation. So finally the answer is XY plus Z bar. Yeah, so this option satisfies XY plus Z bar. So based on the question, option C correct and remaining options are wrong options. So option C correct based on the given question. Shift register. So here shift register question is given. It comes under the sequential circuits. First of all, please go to the question. A shift left shift register and D flip-flops are connected to a synchronized clock as shown in the figure. So here one flip-flop is given. This flip-flop is a delay flip-flop, and one register also given. This register is an 8-bit register, and one more XOR gate also given here. Just go through the circuit. And based on the XOR gate operation, here two inputs are there. From that, one input is 1 here. In XOR gate, any one input is 1, then that gate is acts as an inverter. So that gate is acts as an inverter means NOT gate, which performs the NOT operation only. So how to write the NOT operation? The operation should be here. See, here it is the Q, and it gives always a Q bar. Just you have to write Q complement is Q bar. And later, go through the question now. Assume SR and delay flip-flops are initially clear. So all flip-flops are clear. That means initial the data is 0, and here also output is 0. And XOR gate is no propagation delay. So delay is not applied here. We have to take the ideal condition only. Which of the following option gives the correct binary representation B7, B6, B5, B4 up to B0 of the content of the shift register immediately after 5th clock pulse? Just we have to identify the after 5th clock pulse, what is the status of the register. Initially, the status of the register is 0. So all bits positions 0. So initially it starts from the 0 only. And whenever the clock pulses are connected, this flip-flop output is connected to the XOR gate, so no delay. Then the XOR gate output is stored into the B0, and it performs shift left operation. That means B0 data stores into B1, B1 data stores into B2, and so on. Finally, it performs which operation? Shift left operation for every clock pulse. Now, first of all, I am playing first clock pulse. After first clock pulse, the complete data shifts towards the left side. The complete data shifts towards the left side, and this position, the first bit position, B0 bit position, this position is the output of the XOR gate. Initially, what is the status of the flip-flop? 0. So 0 complement is here 1. So 1 is stored into B0. So now 1 stores into the B0. And whatever the B7 data directly stores into the D flip-flop. Now B7 data is here 0. So the data stores into D flip-flop. In delay flip-flop, input and output should be always same. So input is 0, output of the flip-flop is also 0. Again, after second clock pulse, these data becomes 0, 0, 0 only, because the complete data shifts towards the left side, and this bit shifts to the B1 position. And what about the B0 now? Output of the XOR gate. Output of the XOR gate is again 1, because here the output of the flip-flop is 0 only. So now this becomes 1. And again, after third clock pulse, 0, 0, 0, 0, 0, these 3 becomes 1. These 2 bits shift towards the left side like this. And after fourth clock pulse, 4 ones. After fifth clock pulse, 5 ones. Finally, after fifth clock pulse, the status of the register is 0, 0, 0, 1, 1, 1, 1, 1. So 3 zeros and 5 ones. Then go through the options. Your first option satisfies 3 zeros and 5 ones. So we can select directly option A correct. And remaining options are wrong options only. So this one is also comes under the sequential circuits. Sequential circuits, and it is comes under 2 marks question. So to solve this, if you know all these concepts, we can solve this question within the 30 seconds. But based on the GATE exam paper, we have to solve the 2 marks question within the 2 minutes, because totally we have 65 questions. Those questions has to solve in 180 minutes. From those 65 questions, 35 questions are 2 marks questions and 30 questions are 1 mark questions. So we can solve 1 mark questions within the 1 minute and 2 marks questions within the 2 minutes. But these type of questions, if you know this concept, then we can solve these type of questions within the 30 seconds only, if you know that concept. First of all, you have to understand the complete concept, right? And then go to the next question. Yeah, consider the 4 variable Boolean function xyz is 0, 2, 5, 7, 8, 10, 13, 14, 15 with W as MSB and Z as LSB. Which of the following expression is a valid form of WXYZ? Now 4 variable Boolean operation is there here. To solve this, we required the 4 variable K-map. First of all, I am taking the 4 variable K-map. 4 variable K-map consists totally 16 cells, and the order also given here WXYZ. So always write from the MSB like this, WXYZ. And here you have to write gray code. Gray code is used to write the to draw the K-map, and go through the combinations. So the given combinations are 0. So 0 position is defined here. 2 and 5, 7, 8. This one is a 10 and 13, 14, 15. So 14, 15. Based on the given combinations, I wrote here 1, 1, 1, because this is comes under SOP. Sigma M is given. Sigma M explains the SOP representation. Now it is comes under the SOP. SOP representation always explained by the 1. So that's why I indicated 1 here. Then map this group of cells. Those cells are highest combination. So here I am taking these 4 is acts as a 1 quad. 4 group of cells acts as a 1 quad. All corners we can group like this. All corners. So this is also acts as a 1 quad. Totally, which consists 2 quads. And one more one is there. This one can combines with this one. So this one is a possibility. Just I'm writing with dotted lines. Here one possibility is this one, and one more possibility is this one combines with this one also. 2 possibilities are there. And now this is comes under multiple selection question. So totally 4 options are given. From those 4 options, we have to select more than the 1 option. So multiple selection is nothing but here the answers are more than the one option should be correct. Sometimes one option, sometimes two options, sometimes three options, sometimes four options also correct. So that purpose we have to identify which options are correct here. So that purpose, first of all, I am writing the Boolean expression for these quads. For this quad, all corners means here explains the x bar and z bar, x bar, z bar, and this quad. This quad explains the middle one. Here x and this is z, this is x and z. These two are the compulsory prime implicants. So compulsory simplified terms. So that's why these two are comes under compulsory prime implicant. That means essential prime implicants. And from these two we can write anyone here. Anyone. So here if you take this one, if you take this combination, the answer should be like this here. 1 is there. So wx, and from these two columns y. This one possibility, and one more possibility, this pair. If you take this pair and here 1 w, and from this I am writing now y z bar. Finally, from this the simplified answer should be xz plus x bar z bar plus wxy, or xz plus x bar z bar plus this one wy z bar. From these two, this first option, this one is also correct and this one is also correct. That's why you have to go through the options. One option is given, one option consists this answer, another option consists this answer. We have to select both answers. So because it is comes under multiple selection question. Now I wrote completely answer possible answers of this given question. These questions are comes under the electronics and communication branch question paper, GATE 2026 question. Based on my analysis, these questions are very easy and simple questions if you know the concepts. Please try to understand the concept. And AMDOOR Educational Academy is providing the complete coaching for the GATE classes and B.Tech subjects also. Those who are interested to learn the subjects, or those who are interested to write the GATE exams in 2027 or 2028, please start your preparation from now onwards and take the course from the AMDOOR Educational Academy. Thank you.